Okay, so the next part is they always add something on. And so they have the word or and the word and in between. This is problem 46. And they didn't have a matching and, but I thought, well, I'll just put a matching and. But they do have problems down somewhere in the 60s that have the word and in between them and have something like this. And so it's the same idea there. And so what you do is you solve this. And so 3x plus 4 is greater than 13, excuse me. You're going to take away 4 from both sides. So this is going to be 3x is greater than 9, is that right? And then I'm going to divide by 3. So I got x is greater than 3. And I'm going to put this on my number line. If you want to call this set A, you can call this set A if you want. And so I don't know what my other number is. Should I go find my other number and then put it on the number line? So add 2 here. And divide by 6. So we get x is greater than or equal to -1. Okay, and so this could be your set B. And now I'm going to put -1 over here, and it's solid circle. And goes this way. So there I've drawn B. And I'm going to draw A using the green pen. It doesn't matter which one's which, right? I'm going to put 3 here. All you have to do is have them numerically correct. -1 comes before 3, and then this goes back this way. And we were on a or on this, weren't we? So actually that's the same as the last one we just had. And I'm going to put some on the back here and practice with you with doing them. So this was A union B, which is the same as A or B, right? Those are the same kind of thing. And in this case, when you go to draw, all you have to be is invited by 1 on an or. So all the things down here are invited by 1, right? As I kind of keep, make my dark line be what's invited, right? And so these are all invited by 1. How about -1? Well, it's actually invited by both. And so nothing special about -1, no reason to even talk about it, right? And all the way, what about 3? Is it invited by 1? Well, yeah, 3 is invited by 1. These things are invited by both. So since 3 is invited by 1, it's invited, and so all the way this direction. And so A union B is from -infinity to +infinity, which is all real numbers. Either one. You can put all real numbers, or you can put -infinity to +infinity. You can go look and see what they do for their graphs in the book. They're kind of funny. They just like a number line going both ways, right? And so I think they kind of shorten it up to make it, and then they have different, they kind of go like this one like this, and then they go with a darker pen and go like this above it, and shorter is what they do. And so that's kind of that situation. Okay, so this example right here is an and of that same situation. And I didn't remember those examples being so close together, right? We work this, but don't worry, we're going to do another example. I guess this was just an and then we have this. And so this was my set B. If you want to name them, you can. I drew this one in the pencil, and I drew this one in the pen. So this part would all be the same. This part wouldn't be different. That's open, 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 open. And the and is where they intersect one another, which is in between. It's where they both are. That's where the and is in between. Now this is where it's a little different. This was closed, and so this is both are here at -1, and only one of them is there inviting, right? Only B is, no, A, this is, the green was A this time. A was inviting to the party. A was not inviting to the party, but B was. So I said it right first. So they wasn't invited by both. So this is the and or the intersection, whatever you want to call it, of A and B, these two sets, right, that they've given us. And so this is going to be from -1 to 3. Okay, so before we go and do this example down here, I'm going to flip my page over, and I'm going to grab out another example because I want to make sure that we've done one like this. And I know that I have quite a few of them in the homework. And so for one thing, I didn't have an example where you had to divide by a negative. So I'm going to have something along those lines here. So something real easy like this. And then I'm going to put and then I'll have another set. So the first thing would be to solve each set. And so when I do, I'm going to be dividing by -2. And do you guys remember what you have to do when you divide by a negative on an inequality? I know it's been a really long time. Yeah, you have to flip the symbol. And so when you divide by a negative, you have to, on inequality, you have to flip the symbol. And I know that we haven't done that since chapter 1. So if you want to go watch some videos on that made by your textbook, they're in chapter 1. So this is x is greater than -2. And I'm going to go ahead and put that on my number line. Okay, and so we're gonna do another one and see how we do on it. And so let's say that my other set is x minus 1 is greater than, let's say, -7. And so those are my two sets. Now I want to solve that too. You can call this set A if you want, and you can call the other one set B if you want, or you don't have to go around naming them A and B. That's a choice thing, depending on if it makes you happy to name them or not. I think I'm going to make this or equal to, just so that we can have some practice with or equal to while we're here too. So we're going to add 1, as I was making it up myself, right, to both sides. And I'm going to get x is greater than or equal to, and I'm going to have here -6. So I'm going to come over here on my number line. Now -6 is smaller than -2. So I'm going to extend my number line a little bit. I'm going to put -6 on here. And because it's or equal to, I'm going to put a solid circle. And it says x is greater than, and so I'm going to make my things go this way. And now all of a sudden, because I'm on and, right, and you can call this set B if you want, so I have A and B, I'm on intersect. Where do they intersect? And so over here is where they intersect. It's where both of them are. So this is the solution to the union, to the and I'm trying to draw the solution to the and. And so from here, -2, all the way this way is the solution to the and. All of this is the solution. Josh Lewis likes to make the line really thick, right? What about at -2 itself? Is that a solution? I've only looked here. Right? All of these are solutions because both A and B are there. And means both are there. And, well, what about at -2 itself? Well, only B is inviting to the party, -2, right? It has to be both open, so this is open. All of these things are included right up to it, though. And what about between -6 and 2? Are these things going to get to come to the party? No, they're only invited by B. Got to be invited by both. A stopped inviting people. And so none of these are part of the solution. So this is the and. What about at this -6? No, only one. What about over here? Nobody is sending them to an invitation. Not Abigail and not Bradley. Nobody is sending them an invitation. And so the and for this one is from -2, parentheses, -2 to infinity. That's the and. If I asked you this same problem with an or, -2 is less than 4, or, and then I had x minus 1 is greater than or equal to -7, then you would have the same thing. You would divide by a -2, and you would still flip the symbol. X is then greater than -2, and you would still add 1. X is greater than -6. You would still draw your number line. So here's -6, here's -2, here is open. I almost drew that this way, and I was like, oh my gosh, don't tell me I did that in the first one, but it's this way. X is bigger than, so that's that direction. I almost drew it wrong the second time and thought I had already drawn it wrong the first time, and me not knowing how to edit would have to start again. Often happens to me. I spend hours doing silly things like that. So this is closed. So the picture doesn't look any different, but the difference is or. And or says only one of them has to invite you to the party. So if I called this B and I called this A, not that it matters, then when I go to look at the or, right, because that's what I really want to get, is -6 part of the or? And the answer is yes. It's being invited by one person, B, to the party. All you have to do is get one invitation. So this is part of our answer. What about between? Is that? Oh yeah, they're getting one invitation. What about -2? How many invitations is -2 getting? 1. Well, that's enough. All you need is one invitation when it's an or, right? And so -2 is part of the solution. You don't even have to mention -2. There's nothing special about -2. It got one invitation just like -5 did, and -4 did, and -4.5 did. -2 got one invitation. Now these guys over here got 2 invitations. 2 people wanted to invite them to the party, but they're still just getting to come to the party, right? And so if you're invited to one, you're part of the or. If you're invited to both, you're part of the or. Invited by both, you're part of the or. So there's what the or looks like. So the or is from -6 to infinity. And I think that's all that I didn't have an example of. And I have lots of this practice in your lab. And I think I have the practice from this point right here, where you have this and it's an and or an or, and making the decision on what's going to go, because there isn't too many possibilities for it, right? And I think I have every possibility going on there. Okay. So this one is a compound inequality that's written in one statement, whereas these are compound inequalities that are written with 2 statements, with an or an and in between, and an or is different than an and. This one actually is saying and, is what it is saying when they write it together in one statement. All of these have this look about them, every single one of them. So if you have a number here, whatever that number is, and then you have your variable in between, and you have another number up here, whatever, it's gonna always look like this. Whatever that first number was is gonna go there. to whatever that other number was here. That's how they look every single time. And these were both open. And so they're not really all that hard to deal with. This is an in-between, your variable's in between. So what we have to do to figure out what our two numbers are, our number and our other number, right, is that we have to solve so that we get x in between. So we would want to take away 7 because we want to leave x all by itself. And you have 3 sides, so you want to take away 7 for all 3 sides. When you take away 7, you don't change the inequality symbol. You leave it just the same as it is. So you have -4 now here, down here. Here, these go away, and I have now 4/5 x. And up here, I have 8. And now I want to get rid of the 4/5. So I divide by 4/5, right? Now, dividing by 4/5 is the same as multiplying by the reciprocal, which is 5/4. And that's actually easier to do, is to multiply by 5/4. So I might be saying, put your finger on x and divide by what you see, which is 4/5. But it's easier when it's a fraction to multiply by the reciprocal. So that's going to be my plan. So I'm going to take -4 and I'm going to multiply by 5/4. And on the center, I'm going to take and I'm going to multiply what I had, 4/5, by 5/4. And on the top, I'm going to multiply by 5/4 times 8. So I'm multiplying 5/4 times all of them. I don't change the symbol because 5/4 is positive. If 5/4 was negative, then you would change the symbol. You never change the symbol when you add or subtract. You only change the symbol when you multiply or divide by a negative. So I have multiplying by a positive, no change of the symbol. So when the dust clears and I do the arithmetic here, I get -5. I leave x in the center because the 5 cancels and the 4 cancels. So now I have my number down there and my x in between. And here the 4 cancels with the 8. They were sweet to me. It could be a fraction and it still would be good, and I get 10 up there. And so if this was a fraction, my life would go on. And then my graph of this thing, so this is my answer in set notation. They've asked me to graph it on a number line, so I'm going to graph it on a number line. So here's -5, it's open. Here's 10, it's open. X is in between. So there it is in between. It's an and this one says that you have your -5 all the way this way, right? And this one says you have x is less than 10, so that's open and all the way this way. And it's an and. Where do they intersect with one another as they go, which is in the center. And so people just get where they notice it looks in between. It looks like it says in between. And so it's meaning both conditions. X is bigger than -5 and x is smaller than 10. It has to meet both conditions. Okay, so in interval notation, they asked me for the graph, and then they asked me to write it in interval notation. And so in interval notation, this is -5, 10. And so they asked me for the graph, and they asked me for interval notation. Had they asked me for set notation, there would have been my answer. So there's my answer in all 3 different ways. If you look in the back of the book, and they have this little graph like this for their graph, and they have parentheses like that, that's just as good. And I'm okay with it. It doesn't bother me at all, whatever. Sounds good. And so I'm okay with you using the parentheses instead of the open circles if you like that better. And if you're just like, I want to follow what the book's doing, this is what they were doing when they had us do these problems before. Why have they changed it? Is because they're showing you interval notation. And a lot of times when people use interval notation, they use this notation for graphing. They're 2 different, and so they're all good. It's all good. Okay, well, that's just lovely, and we did a lovely job on that. And now we have, for tomorrow, a new section, but we don't have to worry about that today, so that's good. So this is all the sections for today.